Yo, hello everybody. Classically, let's see if the live is up, and I shall start right after. And it is up. Nice. Yo, hello. The mic is working, so perfect. Let's start. Okay, we left it right here. Stack alignment. Yep. Now format string bug. I have read nothing from like here and below, so if I make any mistakes, just comment on it, I guess, and help me learn with you. If you don't know, we will both be wrong and we will not know it. If manipulated correctly, you can leverage format strings and data bug that's easily exploitable. If manipulated correctly, you can leverage it to perform powerful actions such as reading from and writing to arbitrary memory locations. Why it exists in C? Of course it's in C. C is the classic language that has like a lot of memory issues. Certain functions can take formats specified within strings. Let's look at an example. Int value, okay, we initialize the value and we print it. We print the decimal. This like prints, this stands for decimal. This is like the format that you use to print a value. So this will get this value. This is for float, will get the double value, and this will take the hexadecimal value. And it will print it like this. The \n is to change lines. So it replaced yes with the value. Oh yeah, I am explaining before it even explains it. This is a nice way of say, and the nice way in self-formatting strings. Okay, string concatenation is quite complicated. Let's try print out the same value in hex 3 times. Yeah, okay. What happens? However, we don't have enough arguments for all the format specifiers. What does that mean? Okay, so I think he's actually like accessing memory that he should not have access to. But don't understand why it did here and didn't here. Oh, I'm just straight up dumb. And here we like this. How it is in English word I forgot. Let me search it up. It corresponds. Yeah, this corresponds to this. This corresponds to this, and this corresponds to this. In here, this corresponds to this, and this has nothing to correspond to. So it corresponds to the next available memory. The key here is that prefix expect as many parameters are formatted specified, and in 32-bit it grabs these parameters from the stack. If there aren't enough parameters on the stack, it'll just grab the next values, essentially leaking values of the stack. And why is that dangerous? Okay, let's do the classic Blackboard. Let's just create a new one, a clear board. So let's say that this is where the value is, and in here you have like your password and username. For why not? This does not say use, but imagine this as username. If in the first percentage x, it will get this value. On the next one, because we have given nothing, it will just get the password, and then it will just get the username. This, anyways. How to abuse this? Okay, that's pretty sure. Yep, remol clear and move from downloads. What's the name? FM this to here. Clear and zip FM cut the source. Okay, it has like a buffer. We use the classic gets, which does not check the size, and then we print it. Okay, let's do this, and let's give it ASD. It just prints itself back. If we do percentage %x, it will probably print something else. See, it prints like a value, and if we stack them, it will print like a lot, like more. And this gives us some information. If we run normally, yeah, as expected, but what happens if we input like percent %x? It reads values of the stack. So the stack had those values and it didn't expect them to be used here. This is the technique. If reads value of the stack and returns them as the developer wasn't expecting as many format strings specified. This is the developer's fault, clearly. That's why you should not be a developer. Choose offset to print the same value 3 times. You use this gets tedious, so that this is better way in C. So this just tells it to get the $1 between, I don't know what this does, between tells printf to use the first parameter. However, this also means that attackers can read values as arbitrary offsets from the top of the stack. We can know there is a canary at the top of the, there is a canary at the 6th P. Instead of sending PPP, we just do, oh, that's problematic. P gives us gives us like the memory itself. He's saying that the issue with like using this is that if there is a canary, a canary protection, essentially a canary is on the stack. Let's remove everything. We said like the value is here and there will be a canary here. After you input the value, let's say you put like a regular value, it will check if the canary is the same as before. If it is, it will continue like as normal. If it's not, if like you overwrote it with buffer overflow, it's gonna check that and it's not the same and it will crash the program itself. So like what he's saying is that you can check this value and you can like not overwrite it, you can like give it the exact same value that it has and then like read extra data. And that's the issue. Arbitrary reads in C, when you want to use a string, you use a pointer to the start of the string. This is essentially a value that represents a memory address. So when you use %s format specifier, it's the pointer that gets passed to it. Okay. When you want to use a string, use a pointer. Okay. Essential value that represents. Oh, like you have a value. Like let's say this is what's said, a string. Let's say this is like a double A's, and for example this value will point to this, so this will have the memory address of this. This essentially will be the pointer and it points to this, it points to the address of this. It's a pointer that gets passed. That means instead of reading a value of the stack, you read the value in the memory address it points at. Yeah, exactly as I said, like if this is 0xAAA, this will point to this. It's a pointer that gets passed. That means instead of reading a value of the stack, you read the value in the memory address it points. Yes. Now this is very interesting. If you can find a value on the stack that happens to correspond to where you want to read, that is. But what if we could specify where we want to read? Well, we can. Let's look back at the previous example, at the previous program, and it runs, and its output. Why is it the second value 0 for him? X, 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 and X. Oh, we can see that there is actually a 0 here. What if we add like more? Let's do like double. Oh no, not again. One space 2. Yeah, we see that those like are different from those. Maybe? No? Okay, you may notice that the last two values contain the hex value of X. So those two. Still don't get it. You may notice that the last two values contain the hex value of X. That's because we are reading the buffer. Here it's at the 4th offset. How does he know that? Is it because it's like starts with the 20? To me it starts with 7. It's interesting. Okay, let's run it again and do A, B, C, D, percentage 6, $P. It gives us the address, like 443. Yeah, it's the address of this. Okay, so this will point to this. What if we did like A, B, C, D, percentage 5 $P? This not in NLI. I think it's not in line. NLI in C, I guess. Null pointer. Oh, okay. Let's try again with 4. If it's the same, I'm gonna assume it's the same thing for the rest. It's not. Oh, it's this one. So if we do 3, it's gonna be this one then. A, B, C, D, $3P. Yeah, it's exactly this one. Okay. Oh, this is probably the value of this. No? Why is there so much? Okay, let's continue, I guess. Choosing the offset, and we were here. You may notice that the last two contain the hex value of X. Still don't understand why completely. I mean, if we can write an address that points, we can get an arbitrary right. Okay. As you can see, we're reading the value we inputted. It's true. Let's write a quick pawn tool script that writes the location of the ELF file and then reads with %s. Okay. Let me create it. nanosolve.py from pawn import all p is equal process of .\vul. Payload is gonna be equal to p32 of 0x 41 42 43 44. Payload plus equal b of %6 $P and p dot send line payload and info. Oh no, it's log dot info and Come on, p.clean. And if we run it, it didn't. Why? P is equal to the process, payload is this, 41, 42, 43, plus equal b of percentage c. Oh, it's small p. That's why. Yep. Nice, it works. The base address of the binary is 0x804800. Maybe? Probably it's the same to me, I guess. How does he know that? How does he know that actually? The base address of the binary. How did we like read? How to find? On debug-q dot slash vuln info functions. It is 0849. Yeah, it initializes it here. Okay. So let's do 0x. Let's just copy and paste this. Wait. Why did it not? It doesn't work. Yeah. The reason it doesn't work is that printf stops at null bytes. Oh, and yeah, we have null byte here. And the first character is a null byte. Oh. What? Oh yeah, it's because it's reverse. So she will do it in reverse. Payload is equal to b. And that's $p. Okay, I need to like rewrite the payload. Oh, not again. Payload. No, it did work. So we are like printing the eighth one. So this is the eighth one. And it's correct. Let's break down. We add 4 because we want to address. We write to fill one memory address, not half of one and half another. Okay, because that will result in reading the rogue address. The offset is because the start of the buffer is generally 6p. However, memory address are 4 bytes and long each, and we already have 8 bytes. So it's 2 memory addresses further along, so it's 8. Kinda get it? Now let's place p with an s. That's it. And we get this gibberish. Of course, we'll all stop at null byte strings. Are terminated with them. We have worked out, however, that the first byte of a null file to a null file are backslash this. Why did it say to me like that though? I don't know. Arbitrary right. Likely cell contains a rarely used function specifier percentage, and the specifier takes in a pointer memory address and writes there the number of characters written so far. If we can control the input, we can control how many characters are written and also where we write them. That's broken. Obviously, there is a small flaw. To write, say, 0x yeah to a memory address, we should have to write that many characters. And generally, buffers aren't quite that big. Yep, that's a big number. That's in decimal. 134 million. Let's say 134 million and a half. It's pretty big. Luckily, there are other format string specifiers for that. I fully recommend you watch this video to completely understand it, but let's jump into... Okay, whose video is it? Is it Live Overflow? Of course it's Live Overflow. Why wouldn't it be? Oh, I think I'm close to that video. I think I'm in like 0x10, so I will watch it, but not right now. And I will tell you like on the next one if I understood something that I didn't say. But let's jump into the basic binary. Okay, open it. Classically clear rm all move. Give me 1 second to search something up. Okay, and move the from slash the downloads fm to here. Okay, and unzip. For 1 second I thought that this will not work, but thankfully it worked. Cut auth.c. Main, it has password of 100 and you put it will fgets is a safe one. This will print the password, the words password this to input, and you will input the password that is this size 100, and the size of the password will be the second parameter, and it will be from stdin. Printf, it will print the password, and auth is %i. And if it's 10, then it will put authenticated. Okay, I want to try to like ASD, auth is 0. If I say 10, okay. Can I overwrite it though? If I say okay, let's like copy and paste. Oh, let's do like this, and then I will use the cyclic. This is enough. Auth is again 0. Okay. I thought for sure it will override it, but guess not. Let's see the check. Oh, actually, percentages. Oh, well, that's nice. The percentages gives it like a core dump. Let's do percentage n. Yep. When you select a segmentation file, you know that this is an issue, and it can somehow be bypassed. Let's see how he does it. Simply, we need to override the variable auth, of course. Oh, okay. So we need like firstly to point to the auth, to this value, and then To override it's like its value. Let's do pond debug does q auth info functions this as main, and where is the comparison? Compare. This is compiler source, so it is on this, and let's actually break at this and run. So we are here. It's right before the comparison. Let's set EAX to 0xa and continue. It did not work. Okay, let's run it again. I think I need to step. Step. EAX is not changed. IR. It is, so let's step. Oh, and it will show like authenticated now. Probably. Is it? Yep. So this is like the local way to do it. However, this is not the intended way, of course. I just like overrode the address, and the way to do it is like override the base pointer by 0x28 somehow. So we need to point at this. And what is the address of this? X over, or let's run it, ASD, X over 20x, this. It's this. So we need to somehow make this 10. So we need to point at this and then change value. Okay. As a clover, it's reading with the banners. We check the local using readelf to check for symbols. Readelf does s auth grep auth. Yep. Is it the same? For C. Yeah. He did the exact same way that I like, similarly. This is how you can find it. I found it one way, he found it another way. And let's do nano solve.py. Actually, firstly, from pwn import all. I said all. P is equal process dot auth. So the auth mem is 0x this. And what's next? Payload is gonna be, I want to try like do the cyclic 100, no 200. It's probably not gonna work. Is it? Nope, it's not like, this is not a buffer overflow. This is like different. Let's do like percentage s that, and it crashed. And it cannot reference 0x64. So I need to change the value of EAX. Was it like the beginning? Wait, b main r What is the value of EX? It's this. C percentage P. Oh, it actually gets the value now. Step, 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 step. Why did it not work though? It actually got the 0x10, or was it? Wait, let's run it again. It is R percentage P, R, C, percentage P. It has the correct value. Where does it lose it though? It's correct. Then what? Wait, this as main. Where does it? This is where it prints 134. Why does it skip it? It compares it with 10, and if it is 142. Yeah, but job not equal. And if it is equal, it's what? I don't understand. Percentage P is correct. The value is correct. 0x. Okay. Percentage P, percentage P, percentage. Oh, 1, 2, 3, 4, 5, 6, 7. 7. And this is the most different. This is like the address. Our payload is gonna be P32 of this. No, of auth mem. And before we will do the payload, it's gonna be no. I will try it after, and if it doesn't work like before, I'm gonna do it like after. Payload plus equal B percentage $7 P and P dot send line payload and log dot info P clean, not clear, cleaner, and Python solve. Okay, not too bad. Oh yeah, I forgot about that. Let's try it now. Okay, let's try it again, but with 2. He does it with 6. And I want to see the difference optically. It's gonna be easier to do it like with his way, yeah, but I want to try it anyways. The only difference is for those. Let's like try to do 6 now. Oh, he will do like let's try his way. Print P. No, except I don't want to do it. 1, 2, 3, 4, 5, 6. Okay, and why is it wrong? Oh, it's %10. Okay, I want to try now to do it like with less to see why. So if I'm correct, oh, this, each one of these like corresponds to 2. So if we do 1, the auth will be like 2. 5, what? I'm on the point of, like, I don't understand why. Okay, it decrements by 1 from 5. So if we remove like all of them, it should be 0. It's 4. Oh, okay. It is 4. It starts with 4. Auth is 4 bytes, and we need to write the value. We need 6 to make it 10. But why is it 4? If we do P, it's this. It's 4 bytes because this is 4 bytes. 1, 2, 3. Okay, I get it. This is 4 bytes. So %n will point to a 4 byte string, not string, to 4 bytes anyways, and then you add the rest, the like 6 more bytes in 1, 2, 3, 4, 5, 6. Okay. Yep, I get it. And easy peasy. Yep. Phone tools. As you can expect, Pawn Tools has a handy feature for automating \n format string exploits. So it is payload is equal fmt string payload. That's probably what the reason of the name. Okay, so let's like remove this. Oh, it acts regularly. Oh my god, crazy. It is fmt str payload. It's gonna have 7, and it's gonna be the auth and 10. Let's see if it works now, like as is. Auth is not defined. Oh yeah, it's auth mem. Right? Auth mem, not with this. It might not. Does not much. Oh. I deleted it by accident. Nice. Yep. It's the exact same thing. You can also grab the location of the auth symbol with Pawn Tools. Elf, sim, yep. Like instead of doing the which one was it? Not this? His way. How did you find it? I forgot. The base address anyways. Did he say how he found it? The base address? Am I going crazy? I thought he showed the way. I showed my way with pawn tools. How was his way? Am I losing my mind? Maybe. I don't know. Maybe. It did like that. Yeah, so I'm not that crazy. At least for now. Oh, it is the location of South. That's why. Okay. Stack canaries. Oof. Okay. I will take a break and I will be back. Because why not? Like it's been 40 minutes to like only one, and then there is pi, which consists of the tools. Okay, it's not that much. There is like what's called? It's called Rob Emporium, and I will eventually try to solve the challenges. I think I have managed to do up to the third. I will try to do up to the eighth. There is a heap exploitation as well. I didn't know that. Okay, so this is like the continuation after I finish this stack. I will try to do it, and you will see me fail miserably probably. And yeah, see you probably later in like a few hours.